We know more about the surface of Mars than we do about the depths of our own oceans. But now, scientists from the California Academy of Science created an invention that allows researchers to bring never before seen species from coral reefs hundreds of feet down in the sea all the way up to the ocean's surface. In the spirit of World Oceans Day tomorrow, I spoke with lead author Bart Shepard to learn more.
About 2 years ago, the California Academy of Sciences launched an initiative we call Hope for Reefs, which is really a multi-pronged approach to addressing global coral reef decline. And two big pieces of that I'm involved in are the public engagement and education side of things, and then another piece is research side, looking at the least known coral reefs on the planet.
A lot of these lesser known coral reefs exist hundreds of feet below the ocean's surface, so deep, in fact, that sunlight barely reaches them. This area is called the twilight zone.
The twilight zone, which scientists often call mesophotic coral ecosystems, are coral reefs that are found really below the range of recreational scuba diving equipment, so anywhere from 200 to 500 feet deep. And they've been left unexplored, and so we really wanted to look at them and try and find out what the connections are between shallow and deep reefs, what are the kinds of organisms that live there, what are the threats that they're facing.
Until now, the reefs in the twilight zone have been incredibly difficult to study. Researchers often bring fish to the surface and send them to labs for further analysis. But transporting fish unharmed from 500 feet below sea level all the way to the surface comes with a lot of challenges.
The biggest challenge with bringing fish up from the depth is that most fish have what we call a gas bladder or a swim bladder. It's essentially a balloon that's inside their body that they fill. They inflate and deflate with gas by passing it across blood vessels through the bloodstream. And so that limits their ability to have rapid changes in depth. So if fish are going from deep to the surface very, very quickly, you have simple physics, Boyle's law. Pressure 1, volume 1 equals pressure 2, volume 2. And so if the pressure decreases as you go more shallow, the volume has to increase. And fish ends up with a hyperinflated balloon inside its body, which then causes all kinds of trauma and stress.
There are already methods out there to bring fish to the surface, but they aren't ideal.
Well, we had been doing some diving with collaborators, and they were collecting fish at depth and bringing them up to the surface. And the way that they were dealing with it is they're doing what we call venting or needling the fish, which is you stop at an intermediate depth and you start to observe the fish has some inability to control the buoyancy. They're floating up. They look like they're expanded and puffed up. So what they'll do then is take a hypodermic needle and poke it through the side of the fish into the swim bladder, vent some of that gas off until the fish then becomes neutrally buoyant or slightly negatively buoyant, and then move up to the next step. And I really don't like poking holes in fish. So we wanted to go about this in a different way and look at, is there a way that we can do this that will put the fish through less stress and less trauma and give us more freedom and control over the decompression over a period of time.
Their solution is called the submersive chamber for ascending specimens. I like to call it a fish elevator.
Essentially what we do is we bring the twilight zone to the surface. So when we put the fish inside there, which we typically do at about, say, 200 feet, maybe 180 feet, we'll put the fish in the decompression chamber and we blow a bubble of air in there and seal that up. And as we bring that to the surface, that bubble of air will expand and it'll hold the pressure constant in there. So this thing becomes the world's deepest aquarium, 200 feet deep, and it holds like 2 gallons of water, if that. So that then gives us the ability, we can take it from 200 feet to the surface in a minute if need be, 30 seconds if need be, without any change in pressure on the fish. The fish stay inside in the twilight zone in their own little chamber. So that gives us the ability then to control the decompression over a period of a couple of days, observe the fish, see if there's any signs of stress. If they're stressed, we slow it down. Maybe we'll bump them back down a little bit and bring them a little deeper. It really gives us complete control over the process.
Bart Shepard there, and that study is out in the Journal of Frontiers in Marine Science.